In the digital world, if you mention the number 84C00, they might immediately think of this, the Toshiba Z84C00, which was in fact a CMOS version of the famous Z80. Whilst this might be the case, there in fact was another 84C00, which was manufactured as a microcontroller, but was not as successful. These four strange little beasties are in fact from the MAB84XX microcontroller family. This particular one is the 84C00, as you can see, and this one is one of its counterparts, the MAB8401. They are basically exactly the same, other than the fact that they have different RAM content in them. A most interesting feature about them, as you can see, is the way that they have a standard socket attached to the top. This makes them absolutely marvellous for developers and of course experimenters alike. This particular microcontroller family has a variation on the 8048 instruction set, and all the memory is done by paging, which can be a bit awkward to understand. Hence, to understand it, I wrote this little chart out just so when I started off playing around with it I could understand exactly how it works, because it's a little odd if you haven't ever used page memory like this before. If we use an example, remember there are in fact 4 2K memory blocks in 8, so there are 4 memory bank 0, 1, 2 and 3. You have to address obviously the bank you want, so if we take a simple thing like OC55, here's OC, and if we're 55, this is a jump instruction. So we started by, because we know it's in memory bank 1, it's an F5, so the first instruction will be F5, then as it's going to be here, it'd be 84 as it's a jump, not a call, so it'd be F5, 84 and 55. That would be our jump to location OC55. All the instructions are either 1 or 2 bytes long. There are no 3-byte instructions at all. Here is an 8401 bit in the socket on the board, and I built this up simply to experiment and see it working. The crystal here is 6 MHz maximum, so you can actually see this entire board consists of almost nothing. We have a set of dip switches here and a couple of LEDs, a couple of decoupling capacitors, the crystal, and 2 capacitors for the crystal circuit. There's 1 pull-up resistor down the far side, and that is about all there is. It takes 5 volts of course. So the object of the exercise with this experiment here was about as simple as it could be. What we do is we read in the 4 switches, there's pull-up resistors there, 4 switches into the device, then immediately send them out to the LEDs and loop round. So that's all it does. So simply we're echoing what the switches do should come out on the LEDs. There's a reset button here to reset the system. Okay, we cut the lighting down a bit. If we switch on power supply, we have 2 lights come up in the middle. These 2 correspond to the 2 switches. Very simple. As we add each particular switch, you can see the associated LED comes on. If you press the reset button, it of course switches everything off. Switch it on, it comes on again. So there you go. Nothing really rocket science about that. Ooh, that one looks like it's a bit dodgy. There we go. There we go. Very simple. So I guess it'd be fair to say, what exactly does this piece of equipment have to do with the 84C00? Well, at the radar room we use all sorts of antique pieces of equipment, but there's some things we can't really replicate, and that would be if we need to demonstrate something that requires something like a Morse code message. Not so easy to set up, so the easy way to go about it is to use a modern device, and in this particular case this is actually a Morse code simulator that simulates the transmission of Morse code. So what we decided to do was to use an 8401, I seem to remember, to do just that. And here we see the same thing without its box. Nothing on the top really looks terribly modern, but let's look underneath and you'll see why it was we chose to use the 8401 rather than something like a Z80, which we've used several times before, because there just wasn't any room under the chassis. Here you can see the underside of this device, and right over there is the 8401 on its little board, ready to do our Morse transmission. We've connected a couple of inches wire to this just to see the 8401 doing its stuff. We have a radio turned on to the frequency this is running at. That's 6.7771 megahertz. It's operating under the Ofcom approved ultra low power short range devices, so we're transmitting at only a milliwatt or two. Picks it up on the other side of the room, and that's about it. So if we put that's the power. Now straight away you can see there's a little telltale light that's showing the Morse code transmission going out, and all we have to do now is wait for the 4 valves to come online, and we should hear the Morse code coming out the receiver. So it's a crystal control frequency. There seem to be a lot of valves, but they don't do a great deal. The oscillator, there's the audio oscillator, and there's the output valve. Here we go. So there we go. That's it. Not a lot more to say. Yeah, it seems a pity this little microprocessor, or microcontrollers strictly speaking what it is, wasn't used more, because I think it was a jolly good little job. You know, we have a few more, as you've seen in our piece of conductive foam there, which I'm sure we're going to find uses for, probably in another radar room device. Anyway, thanks for watching.